Writing a linear inequality in standard form gives us another easy option for determining which way our shading should go. In this example, if I'm not super interested in figuring out the slope-intercept form of the line, I can go with the standard form that I was given. X plus 4y less than or equal to 8. Using that inequality and using its linear form, I can get that the two intercepts are 0, 2 and 8, 0. Graphing the solid line, thanks to the equal to on the inequality, I get a line that crosses through those two intercepts. I know once I have 2 points, I can draw the picture of a line, and that's what I've done here. Once you've made that decision, it would be really easy to jump right to shading below. You see the less than symbol, you're trained to know that less than means lower or below. It would be really simple to shade below. Unfortunately for us, that's not always the way it's going to go. Because of some of the unique characteristics of linear equations and inequalities, it's not as easy as just saying it's less than, so we go below. What you can do instead is throw out what's called a test point. A test point is a point that you pick from either of the two half planes. So you either choose a point from the upper half plane or you choose a point from the lower half plane. And after you choose that point, you substitute it into the inequality and see if it works. If it works, you shade that direction. If it doesn't work, you shade the other direction. For the purposes of this exercise, we're going to do two test points, just so you can see what they look like. The two we're going to use are 0, 0 and 0, 4. You want these test points to be as easy as possible to substitute. You do not want them to be complicated. You don't need to pick something crazy. I always tell people to stay on an axis, and if you can use 0, 0, certainly you should. So if I use 0, 0 back in my original inequality, I get 0 plus 4 times 0 is less than or equal to 8. 0 is less than or equal to 8, which is true. That would indicate to me that because this point works, all of the points in this half plane are also going to work. If that's the case, 0, 4 better not work, because I don't want to have solutions on both sides of the half plane. The whole point of this inequality is not that we're going to have solutions everywhere. We shouldn't have solutions everywhere. If I substitute 0, 4 into my original inequality, I get 0 plus 4 times 4 is less than or equal to 8. 16 is less than or equal to 8, which is false, which means I'm not going to shade anything above. So while I ended up shading below, that was not because that the original inequality direction was less than. I could write an inequality where that direction is going to change. Here would be an example, something that looks very similar, but if I was to try to solve it, because I divided by a negative, I end up with it actually facing the other direction. So while I started with it being less than, it ended up being greater than. This is what you graph off of, because you're saying you want the y's to be greater than the line, not x minus 4y is less than, or that's not something that we could easily visualize on a graph. This we could easily visualize on a graph. So while our example ended up being shaded below, that was because of the indication of the test point, not necessarily because it started out as a less than.